Okay, so we're talking about this big question about where everything came from, and we'd like to know where this wonderful solar system we have came from with all this order that we see in it. We discussed that the best theory that we have at the moment is called the Nebular Hypothesis. Nebular meaning dust, nebula. And there's a lot of dust out there. For example, this black rift that goes right down the center of our galaxy is not because of an absence of stars. It's because the dust is so thick there that the starlight can't get through. This is what you see on a very dark night, and even in some smallish urban centers, you can see something like this on a reasonably dark night. There's the Great Rift right in there. But whatever theory we put forward, of course, we wanted to describe the things that we see and give us some answers to why our solar system is the way it is. Why do we have this hot sun in the center? Why are the inner planets so small and rocky? Why are the outer ones so big and gaseous? The other thing we'd like the Nebular Hypothesis to describe then is the tilt of the planets. Why do they have this tilt, and what mechanism may have brought this tilt about? Some of the planets aren't tilted all that much, like Mercury and Jupiter here don't have much of a tilt. Venus is actually upside down. We're at about 23.5 degrees, as you know. Mars is very similar, and you can see what the other planets look like here. Pluto, which used to be a planet, is all sort of at a very large tilt as well. And so where would that have come from? I mean, or should the planets be perfectly lined up, or did something make them all tilt? But when I sort of look at them, they definitely look like just a bunch of beat up planets that had a pretty violent past. And so this is sort of the way they're all left for us to look at. The other thing that the Nebular Hypothesis should describe then are these things like comets and meteorites that fly through the Earth, and the comets that are visible in the sky from time to time. We spoke about comets in a previous video. But for example, you can have sort of a comet like this here that might have so this is the sun right here, by the way. This is a very exaggerated view of our solar system, so you can't even see the inner planets, but you can see Jupiter and Saturn and Uranus and Neptune out there like that. And you see that where Neptune orbits is a pretty messy place in the solar system where it looks like there's a lot of stuff out there. But what that helps us to describe then is that once in a while, one of these things out here might sort of make the big orbit like that and might become a comet. So this is the kind of thing that might get right here and start to melt, and you'll get the blue tail and the white tail and all that sort of thing. We'd have to have a source of where those comets might come from. And indeed we do. You can sort of see the name in here. It's called the Kuiper belt. So the pronunciation can be a bit hard. It's like this, Kuiper belt. Well, I guess you know how to pronounce belt, but that's how it's pronounced. The Kuiper belt has been observed. Things have been seen in it. And so what it is just a bunch of stuff that's way, way, way out there, but it would describe where things, say, like comets come from time to time. They sort of come in from the Kuiper belt, gravitationally attract to the sun, swing around and go back out, and that's good as well. And so that's sort of what we're after then with our big question is describing where it all came from, where the solar system came from, and also we want to make sure that it's consistent with what we see out there, for sure. We don't want a theory that just doesn't describe some things we see. So we can just maybe fix the language up a little bit here. Maybe came from is a little bit magical, but maybe we say where the solar system formed, or maybe instead of where, we could say how. So where it came from is fine to think about, or how the solar system formed probably is a more scientific way of saying about it. And like I said, we'd want some theory that's very consistent with what we see out there. So what we'll do in the next video then is we'll make a little list of some of the things we'd really like a hypothesis or the Nebular Hypothesis to describe to us, some of the things that we see that must be in the theory. Then I'll get in and tell you then how this dust, or what this dust had to do with sort of delivering us a solar system. So a lot more to come.